Hello again. Today we're going to be talking about a concept in calculus known as average versus instantaneous rate of change. So let's get started. First, let's talk about what the difference is between those two terms. Let's say that I've got this graph on the right, and I wanted to talk about what the average rate of change was. Well, the average rate of change is going to be the slope of a secant line between 2 points on the curve, as you can see. The difference is if I wanted an instantaneous rate of change, that's going to be the slope of a tangent line at 1 point on the same curve. So you can see the difference there. Let's talk about how that can be applied to functions in different forms. So first, if I'm actually given the function f of x and I need to find an average rate of change or an instantaneous rate of change, if I want the average rate of change, say from x equals 1 to x equals 7, what I would do is I would plug in those x values into the function and get some y results. And then my slope would just be y minus y over x minus x. So I would get f of 7 minus f of 1 all over 7 minus 1, and I would get whatever I would get when I plug those values into the function. So when I plug in 7, I get 7 cubed minus 7 times 7, and when I plug in 1, I get 1 cubed minus 7 times 1, and all of that goes over the same x as 7 minus 1. And that would get me an answer of 50. So the average rate of change from x equals 1 to x equals 7 would be 50, whatever my units would happen to be for that. For instantaneous, remember, now I have to talk about the derivative of the function. So I have to find f prime of x, which in this case is going to be 3x squared minus 7. And when I plug in 4 into that, because I do want to find the instantaneous rate of change when x equals 4, when I plug 4 into there, I get a value of 41. So the slope of the tangent line at x equals 4 is going to be 41. Another way I can be asked to find those same two things is by looking at a graph. So let's say I have the graph and I don't have an actual function for it, I'm just given the graph. So if I wanted the average rate of change from, say, x equals negative 4 to x equals 0, what I would do is I would actually graph a secant line there, and I would find the rise over run for that secant line segment. And if I do that, I get a rise of 1.5 and I get a run of 4. And that gets me 1.5 over 4, which is 3 over 8. So the slope of the secant line would be 3/8. If I wanted an instantaneous rate of change, say at x equals 3, I would do my best to draw a tangent line there, and I would approximate what the slope of that tangent line would be. So I'd find the rise and the run for that tangent line, and I would get negative 4 over 1, which would be negative 4. And lastly, I can look at tables, and that's just as easy as looking at a function. If I'm given the function, it's just that the y values have already been calculated. Now be careful with this table because my x's are actually called s's and my y's are actually called m's. So that's how I'm going to refer to them in this example, because not everything is in x and y. So if I wanted the average rate of change from s equals 6 to s equals 8, then what I would do is I would look at those two rows of the table, and I would figure out the difference between the y's and the difference between the x's and call those rise and run respectively. And so my rise would be the y value of 3 minus the y value of 0, or in this case the m value of 3 and the m value of 0, minus the s value of 8 minus the s value of 6. Just doing slope like normal, and I would get 3/2. Now, I can't really figure out what the instantaneous rate of change would be at s equals 3, so I have to approximate that using the two s's that are closest to 3. And so I will use 2 and 4, which are on either side of s equals 3. So I do rise over run again, I subtract the m values, which would be 5 minus 10, and I subtract the s values, which would be 4 minus 2. And that gets me an approximation for the slope of the tangent line at s equals 3, which would be negative 5 over 2. So that's kind of a brief discussion over the difference between average rate of change and instantaneous rate of change. If you have any questions, please let me know, and I will see you tomorrow.